All right, well, long time no see. Today we're going to be looking at some smart plugs. These are both made by Sonoff. One of these is a S31 and the other is a S31 Lite. So looking at these, you can't even really tell them apart. It's the exact same housing, and all the external features are identical between these two switches. So this is the S31 and this is the S31 Lite. So what's the difference? Well, the S31 is a Wi-Fi smart device, while the S31 Lite uses Zigbee. And so, they're pretty straightforward. This is not a review video. This is going to be a teardown video. One of the interesting things that I've seen, because I'm not the first person to open these up, is that the S31 uses an ESPHome chip. Now, it's not the ESP32. It's the ESP8266, and so the interesting thing about these is you can flash them with either Tasmota or ESPHome. And so that's what we're going to take a look at. In addition, I would like to compare the internals of these two switches and see what do they really do differently. For this one to have power monitoring, it's got to have an extra power monitoring chip, but I'm kind of interested to see how they switch mains, if they are basically the same thing inside. Because again, looking externally, they're pretty darn similar. So the way you get these things open is you have to pry off this gray end cap. So I've got a very small screwdriver. We're going to see if we can get, pops off relatively easily. And then it's got these side rails at the back. I'm going to slide those out, and that should expose our screws. Now we've got 3 screws. Yeah, there we go. So once we get the 3 screws, this thing just pulls out, and there is our board. Okay, so what do we got in here? We have looks like a relay. Okay, so we've got a 16 amp, 250 volt AC relay. So with these, I'm guessing they would just have to change the plug for European style plug outlet. It does seem to be molded. Yeah, so the plug here does seem to either be melted or glued into the case here. So there is circuitry on the back of this PCB, and if I want to take a look at that, I probably will have to destroy this plug, because there is, from what I'm seeing, no way to get this thing out without cutting this off. Now with this, as I said, this thing is supposed to have an ESP chip, so let me take a look in here. And sure enough, underneath this relay right there is the ESP8266EX chip. And so to reflash this thing, and so we already have pins, they're already labeled here. So you've got VCC, RX-TX, DTX, DRX, and ground. So basically, this is how you can program that ESP8266EX chip. Now, in addition, we have the C chip. This is for the power monitoring. So this thing will do power monitoring, whereas the Zigbee device is not supposed to be able to do that. So that's the chip responsible for that. There's another IC here. I'm not sure if that is either memory or a voltage converter. I think it might be a memory module, but I'll have to dig into that and see. Otherwise, it looks like we've got probably a little power supply, because the ESP chip is going to require a low voltage supply. And then on the back side of this board underneath, I believe that's where the switching is going to be for the main switching. But again, I will have to tear this thing apart to really get in there and see what's going on. So that, let's take a look at the Zigbee module. Okay. So looking at these, it looks like the plug board is all the same. So I'm thinking that this is going to be the same board. Actually, let me look at the markings on this thing. Yeah. So I don't know if you can see that. Let me see if I zoom in. I'm already zoomed all the way in. The power board, it says Sonoff S31 POW V1.2, 2019-01-23. So January 23rd, 2019 looks to be when the main power board was designed. And again, looking at these, they otherwise are exactly the same. So on the right, this is the S31. This is the S31 Lite with the Zigbee. Very, very similar communication style, except the S31 has a little power monitoring chip, whereas the Lite does not. And so here are the programming pins for the S31 Lite. You see it says reset, P02, P03, P04. On the back side of those boards, again, pretty similar, but much less going on the Lite, because it does not have power monitoring, it is not Wi-Fi, it is Zigbee. So let's see. So I am unable, with this board still attached, to see what chip they're using because the relay is in the way. And similarly, I'm going to have to destroy this thing to get underneath it. However, one thing that I know is that the power boards look to be identical, so I will only have to destroy one of these to actually get it apart. And so with that, I'm probably going to destroy the Zigbee version, simply because it's less well documented. I cannot reflash this thing with ESPHome, so it's less useful. And so this is the one that I'm going to be destroying to see what's going on with the power board. And at the same time, I can desolder this daughter board, this control board, and see what's going on there. So I hate to pull a big Clive on you, but, pardon me, and I'll be right back. All right, well, pretty interesting. Got into this thing. Ended up, I did destroy the Zigbee version just as a sacrifice. So let's look at what we found. And by the way, I've traced out this entire thing as well as the Wi-Fi version with the ESP8266. So I will be uploading full schematics for these. The only details that might be missing are a few of the capacitor values because I didn't desolder these and check them out of the circuit. So just something to be aware of. You won't have every single capacitor value, but you'll have pretty much everything else. So the way these things work is pretty interesting. You've got these two boards, and they dovetail together on this end, and then all of these contacts are soldered. So there are actually 8 pins, 4 on the top, 4 on the bottom. So this is the Zigbee version, and you, on the top, basically have the 5-volt rail, and then 3 pins which are not going to be used on the Zigbee version, because these 3 pins would be the ones that would be used for the power sensing. On the bottom, you've got a ground pin and the main switch, and then a couple pins for the LEDs. The switch right here is in the same location for both the S31 and the S31 Lite. That just makes contact here with the main power button on the outside. Other features, this smaller board, you have a little voltage regulator because the power supply for the low voltage side is all here on the main board for both. And so you got a transformer. On the bottom, you've got a PWM IC switching controller, and then some diodes and capacitors and stuff. And so basically this is taking mains voltage and stepping it down to 5 volts. That is done with a little diode bridge, again, into a little switching power supply. That is then being fed all the way over to this board. And so then you've got this little LDO that steps the 5 volts down into 3.3 volts. So on the Zigbee version, on the back side, you have a little Texas Instruments Zigbee chip, and this is the CC2530. Not much other componentry here. You've got a crystal oscillator and then a little array of inductors and capacitors for this antenna. And that's pretty much it. This little transistor actually controls the mains LED, so that's not being switched by the microcontroller. The status LED for the switch is being controlled by the microcontroller. Now on the main board here, again, you've got all this stuff is basically just power supply. You've got a fuse and a couple of varistors for safety. The main switching is being done here by this relay. It's a golden 16 amp 277 volt AC relay. So the microcontroller can send a signal over and it will flip this relay on and off. All right, so now we're looking at the S31, the non-Lite version, so we can start to look at some of the differences on the little control board. So the first thing you'll notice is that the LDO has been moved, and there's an additional little IC right there. This chip right here is made by Chip C. It is the CSE 7759B, and it is just a power monitoring chip. It's going to be using these 3 pins, and then it will spit out a little serial data stream over to the ESP8266 on the back side of this thing. The way it does that, and I didn't destroy this one, you can see a bunch of unused components here on the Zigbee model. So right here is a reading that comes over, and this is taken off of the neutral leg, and so these are going to be 5 resistors. Each one of these is 200,000 ohms, and so you basically get a 1 mega ohm resistance over here. And then you've got another little resistor and capacitor. This then feeds over into that Chip C power monitoring pin just to read off of the neutral. The other 2 pins come over, and here you'll see some unused resistors and capacitors. There's a resistor and a capacitor for each one of these, and that goes to either side of what will be a 1 micro ohm resistor right here. On the Zigbee version, it's just this, which is a jumper. I actually did desolder this, and kind of if I looked under there, I could see it is different. There's a precision micro resistor. It's basically a big chunk of copper, but it's precision calibrated to be, I believe it is. So I think I said micro ohm. I believe it is actually a 1 milliohm, 1/1000th of an ohm. If I'm not mistaken. Now, the reason I know that is because I actually found some documentation from Sonoff on what they're doing, and I don't know if it's meant to be exposed. It looked like part of the testing documentation for this. So that is kind of, again, why I am pretty sure of the resistor value. And again, just to reiterate, it is a 1/1000th of an ohm precision resistor there. The LDO is different on this model. They don't actually use the same LDO, but they do use the same transistor. And again, that transistor then is being used just to switch the LED for the mains power indication. On the back side, basically what you'll see down here, there's just a little memory module and the ESP8266. There's nothing else really interesting going on the back side. It's just a bunch of resistors, capacitors. You can see a little bit over here for the antenna. There's just a capacitor for that. Not really a whole lot else interesting to look at. The only other thing I'll point out that's kind of interesting on these is they do have a lot of test points. So like this one has a test point for ground 5 volt, VCC coming out of the LDO, and then this labeled key is the test indicator for the button. And then I'm not exactly sure what these 2 are, but I believe also you have a programming interface for the Zigbee module if you're into that sort of thing. On the S31 non-Lite version up the top, it does have kind of a full programming array, and you can see some of the pads are lifted because I already have reprogrammed this thing over to ESPHome. So at this point, let's take a look at how to reprogram this thing over into ESPHome. All right, so let's say that you have a brand new S31 in the box and you want to get this thing flashed over to ESPHome. So we're going to take it out, and in addition to this, just so you're aware, you're going to need a programmer. So you're going to need a USB programmer. Now the one I'm using is made by DSD Tech. Its model number is SHV09C5. And so this thing is going to allow you to flash your device over basically UART. Make sure that your programmer is set to 3.3 volts. So mine does that with a jumper here. And then basically you're going to need 4 pins, but we'll come to that in a second. So you're going to need to take your device apart. And so again, get you a very small screwdriver or something to pry underneath this thing to get it released. Now we'll be able to slide out these back rails. Now it didn't want to come out. There we go. All right, so next we've got 3 screws to take out. So you'll need a small Phillips screwdriver for these. All right, now once your screws are out, you can just pull this out of the enclosure, and there is what you're going to be getting at. So these pins on top. Now you're only going to need 4 of these pins. You've got ground right there. You've got the VCC, so this is going to be the power on the right side. And then these next 2 pins, one's labeled RX, one is labeled TX. You do not need the 2 RX and TXD pins. So the real trick of this is attaching to these pins. Now, the first time I did this, I soldered on a header. I've seen people that have set up and they've got little micro clamps that they've used for that. I think there's also, you know, some stuff that people have 3D printed basically to make it easier to clamp onto these if you want. All of those will work. I will say, you know, the downside of soldering things on is it's very hard to desolder it. I did lift some pads whenever I was desoldering mine. However, once you have this thing flashed with ESPHome, you don't really ever need these again because you can always just flash the firmware over the air. But if you're worried about that, think that you might ever want to do this again, it may be worth investing the time to come up with some sort of pogo pin or clamp-on style system. Now that said, since I don't really care that much, I'm going to go ahead and I'm going to solder on 4 pins, and then I'll be right back. All right, so as you can see, I've just kind of freehand soldered these on here. So the next thing that I'm going to do is attach power. So we need the power pin going to VCC. So there's my VCC pin. Okay, the white pin I've got for ground. So I attach the ground. And then on the transmit and receive, you look on your programmer and you hook the transmit from the programmer to the receive of the board. So I've got gray as transmit over here, so I'm going to do gray to the receive pin and then purple to the transmit pin. All right, so I've got all my pins, and again, the mapping is ground over here, the VCC, make sure your programmer's in 3.3 volts, right? Put that VCC on this right-hand side. Then you want to connect, again, the programmer's transmit to the board's receive, the programmer's receive to the board's transmit. Okay, so the next thing we need to do is go to your computer, get ESPHome fired up, and I am going to program this thing. I have found that it worked better on my Windows 10 machine than my Windows 11 machine. But the important thing is whenever you go to plug this thing in to get it set up, hold down this button as you plug it in and keep holding it down until you start getting this thing set up. So basically you have to make sure that it's in boot mode, and basically you have to push this button down, and again, until it starts doing loading, you know, software on here. When it's finally connected and uploading, you can release it, but you want to keep that thing held in while you're plugging it in and until it's connected to ESPHome. So let's go over to the computer and let's get this thing loaded up. All right, so here we are in ESPHome. So I'm about to plug the device into my computer, and as I do, again, I'm going to be holding down the button. Okay, so you'll listen to it connect. All right, and I've still got the button held down, so I'll let you know when I release it. So I'm going to click New Device. I'm just going to name this thing S31 2, okay, because it's going to be my second device. Hit Next, then hit Connect. And again, I'm still holding that button down. I click on the COM port for the USB, hit Connect. All right, and so I will let you know when I release the button. It's going to be in just a second. All right, at this point, you're probably fine, but I like to hold it until it says that it's uploading just to be sure.
Okay, I've now released the button since it's installing. Again, you can pretty much release it once it says that it's actually, working on things, but I tend to hold it down until I'm absolutely sure that it is fully communicating and installing software. So this takes a couple minutes, and once it's installed, I'm going to unplug the device and let it power cycle. I've found that that seems to be necessary to get it to connect to Wi-Fi. So you'll see it'll say finding device on the network, and my experience is if you don't power cycle it, this is gonna fail. So I'm gonna let it fail, and then I will unplug and plug the programmer back in with everything still connected. Okay, so there it is. It's failed. So let me hit close. Now all I'm gonna do is I'm just gonna unplug and re-plug the programmer in. You don't have to hold the button down at this point. We're just gonna do this to power cycle. All right, so now it's power cycled. You should, in a second, see it come online once it connects to Wi-Fi. Okay, there it is. It's online. We've got a little indicator you can't see, but on my screen, I need to set this device up in Home Assistant. So we are now flashed, and we can now just modify this thing as an ESP device through the regular Wi-Fi interface and reprogram it as we want. So let's look at setting this thing up to be an S31. Okay, so we are on the ESPHome website, and there actually is already a configuration for the Sonoff S31. I am not the first person to do this. So it already tells you, hey, here's the GPIO pinout, and it gives us a basic configuration. So we're going to take, and I'm going to put this logger code over where it has enable logging. I'm going to go ahead and put that in there. There seems to be some issue on this with that power monitoring chip because it uses the UART, that basically the logger can have some interference with it. So there we go. We've got the logger set up. Next thing to do is now we can basically just take all the code below this, copy it, and then back into our YAML, just paste it all in down here. And that's pretty much it. You can rename anything you want if you want anything to be kind of renamed in here, but it will just work like this. I did want to mention here one small change that I have made to the YAML code compared to the default on the ESPHome website. That is right here in the Wi-Fi. I've actually set up some status stuff for the LED, basically to come on whenever you're connected and to turn off whenever you're disconnected. In addition to this little change, that also requires that the light for the LED be set up a little differently. So if I scroll down to the bottom here, you will see that I'm actually using a Lite platform status LED. Basically, this will configure the LED to work as an error indicator if there's any error, but it also gives you control over the LED otherwise. So basically, if there's an error state, the LED will function as a status LED. If there is no error state, then you can do whatever you want with it. And so the reason I've done this is that this is more similar to the way the default S31 LED light works. Basically, it will always be on if you're connected and everything's fine. If there's some error, it's going to blink at you. So anyway, I just did want to mention that you may want to do that if you want it to work more like the original S31 programming works. So you can see my other test device is already here. It's been running a little bit. And so, yeah, this seems to work just fine. All right, so just to give this thing a quick little test, I've got just a battery charger. Okay, you see it comes on, and if push the button, turns off. So it does seem to work. Now I will go into my phone. And so here you can see I've got the phone out, and I can turn it on and off remotely. So yep, it does seem to be working. So with that, that will be the end of this video. Now, once again, I will be uploading
fully worked out schematics for both the Zigbee and the Wi-Fi model. So the S31 and the S31 Lite. So if you want to tinker with these, feel free. Like I said, I'll post them up. And with that, I guess I'll just say, as always, I appreciate your time. Thanks for watching.